An Introduction to the Theory of Automorphic Functions by Lester Ford. Chapter 2, Groups of Linear Transformations. Section 13, the Fundamental Region. Before proceeding further with the study of the modular group, it is desirable to introduce the definition of the fundamental region, a conception of the foremost importance in the theory of discontinuous groups. Definition: 2 points, 2 curves, or 2 areas are said to be congruent with respect to a given group if one can be transformed into the other by some transformation of the group. Definition: a region such that no 2 of its points are congruent with respect to a given group, such that every region adjacent to it contains points congruent to points in the given region, is called a fundamental region for the group. Figure 6 shows a fundamental region for the cyclic group of 6 rotations, z, e to the 2ni pi divided by 6 times z. No 2 points in the shaded region can be carried into one another by rotations through multiples of the angle 2 pi divided by 6. But points in any adjacent region, and in this case any other point in the plane, can be carried into some point in the region by such a rotation. The shaded region in Figure 7 is a fundamental region, or parallelogram of periods, for the group of the doubly periodic functions z, z plus m omega plus m prime omega prime. The vertices of the parallelogram are the points 0, omega, omega prime, omega plus omega prime. We note that the rays bounding the region in Figure 6 are composed of congruent points. Strictly speaking, only one of these rays should be considered as belonging to the region. A similar remark applies to Figure 7. No point can have 2 congruent points in the fundamental region, for these 2 points being congruent to the same point would be congruent, which is contrary to the hypothesis. It is clear that the fundamental region is not uniquely determined. We can, for example, add to the given region a small adjacent region which has no 2 of its points congruent, provided we remove from the original region the part congruent to the added region. The new region is then fundamental. We note also that any region congruent to the fundamental region will also serve as a fundamental region. For example, the unshaded regions in Figure 6 and 7 are congruent to the shaded regions, and any one could be employed as a fundamental region. An Introduction to the Theory of Automorphic Functions. This book was written by Lester R. Ford, M.A., Harvard, lecturer in mathematics in the University of Edinburgh. It was published in 1915 by G. Bell & Sons Limited, London, and is now in the public domain. It is read by Jim Renhold, with programming and illustrations by Jim Renhold in 2019. Thank you for listening.